Yeah.
Do
So,
you want to share your PowerPoint again? Let's get that out there first.
Let's try that.
Come on, we can do it. We can do it.
I might just try going through this way and see if that makes a difference. There we go.
You're right.
Yeah, I mean, I can't see myself, but it'll be fine.
I'll leave you to it. Take
Great,
care.
thank you.
I'll let you know if you crash again.
Thanks.
Bye.
Okay. Hi everyone. Again, sorry about the first time. As I said, my internet just decided to give up on me, and I can't see myself. Although now I have my laptop and I have my iPad here, so I can see that I'm still going. So I'm going to talk to you a little bit about lockdown maths because for those of you who don't know me, I work for a mathematics organisation and I'm very passionate about maths and the great stuff that's going on in maths. And at the moment, obviously, with homeschooling and everything else, teachers find themselves in a tricky position because we can't necessarily teach new concepts to children because there's a lot of challenges around having manipulatives or being able to get that feedback or being able to go at the pace of the child. And so I was thinking about, okay, what should we be doing? And so my suggestion is to think very much about mathematical thinking. So for me, mathematical thinking isn't this kind of really scary thing. It's about seeking patterns. It's about identifying what's the same and what's different about anything really that I'm going to focus on maths. And it's also about recognizing the kind of underlying structures of maths. And this can be really straightforward. So if you have a reception child, you can count with them 1, 2, 3, 4 objects, and they can recognize that every time they have 4 or something, it's 4, and it's always 4, and you can move them around and do all sorts of things. So I'm going to do some maths with you. This maths you can share with your pupils, whether you've got things going on at home with those pupils, or whether you're doing working with key workers. It would be great if you could do the maths. So I'm going to give you some pause points, but I think depending on where I cut off, as I said earlier, I can't see you doing the maths. So if you do it or not, fine, but I will talk you through a few things. So we are going to have a look at consecutive numbers. So instantly we're thinking about, well, what is a consecutive number? What makes these numbers consecutive? And so I have 2 sets of consecutive numbers here, 4, 3, 2, 1 and 8, 7, 6, 5. And what we're going to do is we're going to make 2 two-digit numbers from each of these sets, and we're going to subtract them. So again, that's getting pupils to think about, well, what happens when we subtract? For this, we're going to look at positive difference, but you might actually, with older children, have a look at negative difference as well and see if the patterns that we're going to see work across those as well. So to give you an example, I am going to make 41 subtract 32 and then 85 subtract 76. So what I'd like you to do first is to have a go at those subtractions and find the difference, find the answers. Okay, so you should find that the answers are both the same. So that instantly gives some really interesting things to think about. For children, the numbers are completely different. You know, they don't share any digits. The second set is much greater than the first set, and so on and so forth. And so the fact that they have the same difference is really, really interesting. But then we can go further than that, and we can pick another pair of two-digit numbers. So this time, I'd like to have a look at 32 subtract 14 and 76 subtract 58. Now, you might already have conjectures about this, ideas. So you might expect the difference to be 9 again. You might expect the difference to be the same again. You might have no real thought about what might happen. But I'll just give you a moment to find the answers to those. And so this time, the difference is the same across the row, so across the 2 examples, and we have 18. So again, pupils might be thinking, well, is the next set we're going to do going to double because they recognise that double relationship? So already we're starting to think about patterns, think about mathematical thinking, and so on and so forth. And then what we can do is see if we can find all possible combinations of 2-digit numbers and explore what happens. So in these examples, I'm not going to make you do them because of their time and because you've all probably, like Graham, had a few beers. But we can have a look at all those different combinations and find where the pairs of numbers have the same difference. Now, at this point, we might need a little bit of nudging to think about what's going on. So to focus on 41 subtract 32 and 85 subtract 76, have a close look at where those numbers have come from in the original set. So 41 is the first and fourth number of my set. 85 is also the first and fourth number of my set. 32 is the second and third, as is 76. So again, we're thinking about introducing the kind of ordering of numbers with children as well. And if you look at all of my other examples going across the rows, you can see that I have selected the numbers very, very carefully. So if we look at the last example, 42 subtract 31, you have the first and the third, and the second and the last, and so on and so forth. And so that can be really interesting for children to look at and see if they can work out then why this works in the way that it does. Now, children might just spot the pattern, but older children, even into secondary school, might start to think about what's going on here. Now, the purpose of this task is to spot those patterns, to generalize, to think about what's going on, to get excited about maths. But actually, at the very base of it, you're practicing lots and lots and lots of two-digit subtraction, which can't be a bad thing for consolidating practice. So finally, we can think about where we can take it next. So it might be that children or you think that these examples have been chosen by me and that they happen to work. But what about other sets? Would 5432 and 7654 give the same results? And then we can think about consecutive odd and consecutive even numbers. So hopefully you've done a little bit of maths. Some of you might now go off and do more maths, if anything like me. I just wanted to share some ideas, and I think my kind of bottom line is, if you are setting tasks for children and whatever that might look like, or if you're working with your own children, what patterns can you see and how can you get kids interested in maths? Thank you very much, and hopefully Graham is there having done some maths.
Paul appeared then. Did you see that? Do you know what? That was brilliant. Thank you so much, Lisa. I'm glad you managed to get back on.
I'm glad too.
I was one of those children at school that really didn't get maths at all. I really didn't enjoy it. And I think it was because the lessons I had with teachers were just so dry. I didn't see the point of it until I started working in a shop. And when I started working in a shop, we didn't have tills that worked everything out for you. I didn't really see the point in maths. But now it's just like, it's like magic, isn't it? When you start to find patterns of things in maths, it's just like,
yeah, I agree. And there's so many patterns, there's patterns in nature, there's patterns in, I was looking at my licorice all sorts earlier and trying to estimate whether, hold on, I can show you. Hang on. Sorry, I'm distracting myself now. I was trying to decide whether this kind of licorice all sorts or this kind of licorice all sort, which had more licorice in.
Nice.
And that's mathematical thinking, and it's interesting.